whenever we talk about the basic parts of a polynomial function, okay? So what is going to make it a polynomial as opposed to a polynomial function as opposed to anything else? Okay? A polynomial function basically just means that from any point from the left side of my graph to the right side, I can draw this picture, this function, whatever you want to call it. Okay? I can draw this without picking up my pencil. Okay? What you've done already with quadratics, a quadratic is a polynomial function. Okay? Because you can draw any sort of quadratic, basically just like you've done before, and you could draw it without picking up your pencil. Okay? Obviously, we'll pick it up to draw the arrows or whatever. It may look like that, it may look like this. Okay? But I can draw it from left to right, or right to left, without picking up my pencil. Okay? So, just like I did before, whenever we get into like what's called a cube, or if it's to a fourth power, I can draw anything and to where it would look like that. Okay? Again, I can draw this without picking up my pencil. Obviously, there are going to be times that you're going to pick up your pencil whenever you draw that. That's okay, but just understand that's basically the main characteristic of a polynomial function, is that there are no restrictions whatsoever as I draw this or graph this from left to right. So then in the back of your mind, or hopefully at the front of your mind, if I can draw this without picking up my pencil, what do you think my domain is going to be every single time of any sort of polynomial function? Negative infinity to positive infinity. Okay, so with any of these, so I would put somewhere in here with any that your domain is going to be from negative infinity to positive infinity. Now, we'll get to that later, but that is your main thing, that if you don't have to pick up your pencil, then I can draw any function from negative infinity to positive infinity. There's no restriction. It's automatically going to go from the left to the right side, and it's never going to stop. Okay, it's going to keep moving off to the left, and it's going to keep moving off to the right. Okay, so just kind of know that there's really no place to kind of fit that in, but just to know that anything that we deal with is always going to go to the left, and it's always going to go to the right. Depending on if it goes up or down is going to vary on what type of function we have. Okay? So with any of these, whenever we write them, any sort of polynomial in standard form. So I'm just going to kind of take each one. Whenever we talk about writing it in standard form, that means we're going to start with, or first off, let's go with a polynomial function. If it's a polynomial function, one, we can draw it without picking up our pencil, but if it's a polynomial function, then each power or exponent is a positive integer. It's going to be anything to the first power, to the second power, to the third power, to the fourth power, to the fifth power. Okay? Positive counting numbers. That means if it's a positive counting number, what type of number can it not be? Can't be a negative. If it's a counting number, so it can't be a negative, so we know that. What else can it not be? A what? Okay, it can't be imaginary. What else? A fraction. Okay, so it can't be a fraction. It can't be a square root of an x variable. Okay, that's a square root function that's over here on the board, or on the wall rather. So of my four, of A, B, C, and D, which one automatically, before we even get started, is not a polynomial? Which one? B is a polynomial function. Okay? Because the x isn't underneath the radical, I just have a number that is a radical. C. Okay? Why is C not a polynomial? Because of that negative exponent. Before I even get started, I know that C is not a polynomial because x is taken to the negative 1 power. Now, whenever we write it in standard form, okay, so just kind of off to the right, what it means to be in standard form is that each variable is listed in order from greatest to least power. So if I'm going to look at any of these, I'm going to look at the powers from the highest power to the lowest power, and I'm going to go in order. So like on A, if I have f of x equals negative 2x to the third plus 5x plus 8, does it go from the highest power all the way down to the lowest power? Yeah. Okay. Even if I'm missing something, so I don't have an x squared, that's okay. I have an x to the third, I have an x, and I have an 8. What I probably am going to end on most times is going to be a constant. Okay, it's not always going to happen, but normally that's what will happen. Okay, so A is already written in standard form. Is B written in standard form? No. Okay, so what do I need to do to write it in standard form before I even start? What needs to change? What needs to go first? The x to the fourth. So this needs to go first. So the sign and whatever the coefficient that I have in front of it is going to go first. So I'm going to have, if I'm going to rewrite this, I'm going to have the square root of 2 x to the fourth minus 0.8x to the third minus 12. So now we know C is not a polynomial. Now, is A, B, and D all in standard form? Yes, so we have everything in standard form, so we can kind of check that off the list. I didn't have to change A, and I didn't have to change D. Now, the next part talks about, it says, state its degree. All the degree is the highest power. So whenever we talk about the degree, it's just going to talk about the highest power. So first off, we know that A, B, and D are all polynomials. What's the degree of A? 3, I heard. What is the degree of B? 4. What is the degree of D? 3 again. Okay, so if it's already written in standard form, we don't have to rewrite it. Oh, it's a 2, not a 3. I'm sorry. I read that wrong. My fault. Whew. Long day. I was wondering why I had all these funny looks at me. I had all these people looking at me like I had a third eye on my forehead or something. Okay? So we've written it in, we've figured out if it's in, first of all, we figured out if it's a polynomial. Now we figured out if we have it in standard form. Okay? The next thing is to write the degree of whatever our highest power is. Then the next part is what type of polynomial function do I have? Okay, so I would write over here off to the left, whenever I have the type, if I just have x equal to a number, that's just what's going to be called a constant. If I have x to the first power, it's linear. If I have x squared, it's a quadratic. If it's x to the third, it's going to be what's called cubic. And then x to the fourth, it's going to be quartic. As far as my different types, what's the type of A? Cubic. What about the type of B? Quartic. And then the type of D? Quadratic. So then the last thing is going to deal with the leading coefficient. Okay? All the leading coefficient is the coefficient in front of the variable with the highest power. I do usually whenever I write the leading coefficient, I'll just basically abbreviate it as LC. So what's my leading coefficient of A? -2. Okay, it's everything. The positive and the negative all go with it. What about my lead coefficient of B? Square root of 2. Okay, square root of 2 is just a number. Okay, it's like 1.4125 something or other. I don't remember how else it goes. Okay, square root of 2 is just a number. Okay, we're just going to write it as square root of 2. Then what is my lead coefficient of D? 1. There's nothing there, right? So if there's nothing there, it's just going to be 1. Okay, if I would do this and if I would go quick, I would just basically have -1.6 x to the second minus 5x, and then I'd put the plus 7 on the back end. What's my degree? Degree is 2. What's the type? Quadratic. And then what is the lead coefficient? -1.6. Now, the next part where it says to evaluate f of x when f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when x is equal to 3. All it means to do whenever it says to evaluate, that's just a fancy word for plug it in. So basically all I'm going to do, if I have f of 3, I'm going to take 2 times 3 to the fourth power minus 8 times 3 to the second power plus 5 times 3 and then minus 7. Now, it's completely up to you as far as how you do it. The one thing I would tell you, if you're going to plug it in and you're just going to plug it straight into the calculator, make sure you put parentheses around whatever number that is. Okay? Because if you get in the habit of it, then you won't have to worry about if you have a negative. If you always put that value inside the parentheses, you will be just fine. Okay? As long as you write that part out first and then you want to type it in, I have no issue in that. Okay? Realistically, what's going to happen? You're going to have all this, and you're just going to type it straight in, and you're going to hit the enter button, and it's going to spit out some sort of number. Okay? It's going to spit out, what is it, negative 89? 98. I knew I had the right numbers, just in the wrong order. Okay? I understand that you're just going to basically tie it in, and you're just going to get negative 98. Okay? What? It is positive? Okay. So, even if you, now, I have no issue in you basically multiplying 2 times 81 and going 8 times 9 and plus 15 minus 7, or doing it as 162 minus 72 plus 15 minus 7. If you want to write it all out, that's fine. Go for it. If you're just going to type it straight in, that's fine. The biggest thing I want to make sure is that you at least show me what you put in there. Okay, and how you typed it in there. Okay? I don't want to just see 98. I want to at least know, because then if you make a mistake, I can at least figure out where your mistake is. So whatever you type in to your calculator, I need to see how that's listed. Okay? Parenthesis and everything. Because what happens is, if you don't do a parenthesis, like where it says you try, right below it, and like on number 5, if I don't plug in, or if I don't put it in parentheses, and if I just basically try to, if I go 3 times negative 2 to the 5th minus negative 2 to the 4th minus 6, and you just type in times negative 2 and then plus 10, you're probably going to get it wrong. Okay? If you do it this way and you don't put anything in parentheses, you're going to get it wrong. Okay? More often than not, something's going to happen because you have that sign, and you've got to make sure that whenever I type it in, that I put parentheses around every single value. Because if you don't, that's a 4th, you're probably going to have a sign error somewhere. Okay? Because the calculator just reads it as it reads it. Okay? To be honest with you, where everything would probably go wrong is right here. Because the calculator would see it as a negative and a negative. What happens to a negative and a negative? Turns it into a positive. Okay? If you just type it straight in, it's going to turn that to a positive. Well, 2 to the 4th is 16. But negative, so it would be basically, I would be adding 16. The problem is, what's actually happening right here is I'm subtracting 16. Okay? And it's going to give you the wrong answer. Whatever value you have to put into your, or whatever value you're putting into your function, you need to put a parenthesis around it. Okay? I don't care if it's positive. Get in the habit of putting a parenthesis around it. That way, when it's negative, it's not going to be as big of a deal, or you're not going to have to change up how you input into your calculator or how you input it into your equation. Ask some pretty simple questions. So, whenever you have an odd degree, so the first 2 graphs, the 2 graphs that are on top, what do you notice about the arrows in terms of the direction that they're going? They're going in opposite directions. Okay, good word. So if they're going in opposite directions, what word, or what letter, does opposite start with? O. Glad you noticed that. Very good. Now, whenever we talk about the degrees, what word is in both of those? What is the degree? Right here and right here. Odd. What letter does the word odd start with? O. So odd and opposite both start with the same letter. Okay? Coincidence? I think not. So anytime you have an odd degree, I don't care if it's to the third power. Think about if you have a, the first thing you guys drew, or the first thing you guys graphed whenever you were in Algebra 1 was what? Straight line.
Oh, yeah.
Okay? X to the first power, right? Y equals X.
I sure do miss those.
Which directions are they going? Opposite directions. One's going up, the other one's pointing down. Same way, if we get y equals x to the third, you've got the left side going down, you've got the right side going up. Even if we have something like y equals x to the third minus x squared, it's still going to have one going down and one going up. Okay? It doesn't matter the power. Even if I had, it would do the same thing if I had y equals x to the 5th. It would do the same thing if I had y equals x to the 7th, x to the 9th, x to the 11th. It doesn't matter. They're all going to do the same thing. One's going to go up, the other arrows, one arrow's pointing up, the other arrow's pointing down. They are going to be going in opposite directions. Okay? Whenever we talk about going in opposite directions, we're talking about our y values. Okay? As I move to the left, in this case, it's going down. As I move to the right, or going in a positive direction, it's going up. Now, with each of these, though, what do you notice about the lead coefficient? They're different, right? The one on the left, it's positive. Which side is positive? Which side is going in a positive direction? The left or the right side? The right side, okay? Right here. What about for the other one? Well, which way is the right side going? Negative, right? So what do you think that lead coefficient is going to tell us? Huh? Well, yes. What if it's positive?
That's positive.
Okay. What's it tell us about our graph, though?
That the right side, which way the right side points.
Which way the right side points. Okay. So your lead coefficient, so somewhere kind of, you can draw it on there. So your lead coefficient tells you let's go with which direction the right side points. Okay, so your lead coefficient will always tell you what the right side does. It'll tell you if it's pointing down or if it'll tell you if it's pointing up. Now, is that always the case even, and I'm going to jump down here, does it do the same thing down here on the even powers or even degrees? Yeah. Okay. It's still going to tell your right side what to do. It's just a matter of, are they opposite of each other or are they going in the same direction? Okay? The even ones are going, in the same direction. The odd powers are going to go in opposite directions. All right? Now, the notation, this is where this is the hardest thing to get students to understand. Okay? All that this means right here. Okay? All it means is, which way is positive infinity? And whenever I'm talking about my y value, up. Which way is negative infinity? Down. whenever I'm talking about my x value, which way is positive infinity? To the right. Which way is negative infinity? To the left. Okay? So whenever it talks about f of x, that's just the fancy way of saying y. Okay? So basically all that means is y goes up as x moves right. Okay? All this circled part means that x goes up as y moves to the, or excuse me, as x moves to the right. As x goes closer to positive infinity in this direction, the graph's just going to keep going up. So then, what do you think that the, let's go a different color here. What's a way to write this here? Which way is y going? Y goes down as x goes left. Okay, so y is moving down as I keep going to the left. Even as it travels down, it's still moving left ever so slightly. Okay, some will really move left. Some will just look like they're almost going straight down. So then, how would I write this one here? How would I write it in terms of words? The one that's in the box over on the right side. What is y doing? Y goes up or increases. Don't use the increases because we'll have to talk. We'll talk about increasing and decreasing later. So y goes up as x moves left. Same way then whenever we talk about here, y goes down as x moves right. Now, last thing before I just kind of end it. Is there any difference? What's the only thing that's really different about the even power? Yeah, they go the same direction. Okay? So no matter left or right, your lead coefficient is going to tell you, is it pointing up or is it pointing down? Okay? Everything else is the same. Notice that as x moves to the left, or excuse me, y is going down as x moves to the left. Y is going down as x moves to the right. It doesn't change. Okay? They're not opposites of each other. They're going to be the exact same. So in terms of like how I would write it, you know, y goes up, y goes down. Whatever I write to the left side or whatever I really write to the right side, because the right side is always going to tell me what's going to happen. Okay? It's just a matter of checking to see, is the left side the same or is it opposite directions? Okay? Bless you.